Good afternoon, friends. How are you all? I am so. Okay, today I'll describe step by step how the relay energizes and closing the locomotive circuit breaker DJ or VCB. This is its control circuit because VCB is in 25 kV side, but we cannot work directly in the 25 kV side, so we are using 110 volt DC circuit with electromagnetic and electronumerical circuit to avoid hazard. So now see, when I close the battery switch, the spark supply is receiving. See how. Now see the last branch Q118, it has it will energize because the C118, the C105, the C106, the C107, the Q44 relays are normally close contact relays. That means when it is not energized, this C118, C105, C106, C107, Q44, this contact will be in closed condition. So the DC positive will come through this path to energize Q118. Q118 positive is getting from the positive side and negative is permanently connected, so it will be energized. First it will energize the Q118. See how. When Q118 will energize, that means after closing the battery, immediately Q118 energizes. Okay, Q118 energizes. Now the action of the driver will start. What he will do, he'll operate his switch box one by one. First he will press BP1 DJ if he is in cab 1. Then he will play, first he will close the BL DJ, then BP1 DJ. Then your pantograph selection, after selecting the pentagram from 0 to 1 or 0 to 2 as per cab 1 or cab 2, this ZP2 will be closed. This ZP2 will be closed. Now he will close the spring switch BLR DJ and hold for some time, and then he'll release it. And GR, that means the transformer tap changing graduator, this remain in zero. This remain in close condition. This remain in close condition. Okay, GR will be energized and GR will be in close condition. So your Q45 will be energized. Your Q45 will be energized. After the driver action, we can see that Q45 will be energized. See how. So Q45 is energized, but it needs driver action mainly in the switches. That means BP1 DJ, BL DJ, Pento selector switch, then BLR DJ is a spring switch. If you press it, it will be closed. Then if you release it, just like our calling bell switch, it will be released. For few seconds, we are driver is holding that thing to close the DJ. So GR is in closed position, so your Q45 will be energized. When Q45 will be energized, its contact will make in the Q44 branch, you see the first branch on the top there is a Q45 contact. When Q45 relay will energize, it will close the contact of Q45 on the first branch on the top, and from there it will come Q118 is already energized. First Q118, so this contact is closed, and your so notch, if it is in the notch position, that means it should not be in the mid of the notch. Suppose your notch is 1 2 3 4, so it should be in the full notch, not to be in mid notch between 1 and 2 or 2 or 3. At that time it will be in closed condition, so your Q44 will be energized. After energizing Q45, your Q44 will be energized. See how. So you have seen that Q44 is energized. After Q45 energization, Q118 energization. Now two coil is responsible for DJ closing, that is Mtdj and Efdj. This will be energized. How? You see, already our Q44 and Q45 energized, and in the Efdj Mtdj branch there is a contact of normally open contact of Q44 and normally open contact of Q45. Keeps here normally in closed condition till the starting of the Arno converter. So this will in closed condition, and in Mtdj branch there are so many normally closed contact. It will be in normally closed. These are all the delay contact, safety relay contacts. If any one of it will energize, then your DJ will trip. Mtdj will enable to DJ to trip, and Efdj is helping to close the DJ. So your Q44 and Q45 energized. Now through this Q44 your Mtdj will be energized, and your Mtdj will further energize this Efdj. But in the Efdj and Mtdj there is another two contacts. That two contacts is these two contact I have not written shown here. Let's see. These two contacts I have forgotten to write. So these two contacts is your DJ and C118. You see, C118 will be energized when this Q44 and Q45 contact will sit. So C118 will energize, and these two contacts just above the EFDJ. One is C118, so it will be closed, and another contact is DJ. So till now it has not closed, so it will be in normally closed condition. So these two contacts will energize the EFDJ, and EFDJ will be closed. I am showing you how it is happening. Friends, in the Mtdj branch, there is a contact of Q2B Your pressure is if your pressure is normal, then it will be closed in closed condition. Sufficient pressure is if available, then it will be in closed condition. So your Mtdj now easily can be charged, but for Efdj already our C118 is energized. So DJ in open condition, so it's normally close contact will be in close condition. So both Mtdj and Efdj will be energized, and your DJ will be closed. Your DJ will be closed. See how? So friends, we have seen first the Mtdj will energize, and after that the Efdj will energize, and these two coil energization will enable to close the DJ. Mtdj will release the air in the DJ closed circuit left side chamber. Already I have shown in the previous slide, and enable Efdj to press the DJ to close from the right side air pressure, which is coming due to energization of the Efdj. So Efdj is closing DJ for closing DJ, and Mtdj for maintaining it, and if any of the safety relay will trip, then it will de-energize the Mtdj, and Mtdj will allow the left side chamber air pressure and DJ will open. This is for protection. So I think a basic idea about the controlling system with this 110 volt. With this 110 volt DC, we are controlling 25 kV as well as other voltage system, which is our harmful for our body. So in this way, we are using two circuits, power circuits and control circuit. Power circuit is for high power, high voltage, high current, high electricity, high energy. So we cannot directly operate it. And another thing I have seen, some manual switches also we need to operate to close this DJ, that is divert responsibility. In the desk he will close for Q45 energization, BP1 DJ, BL DJ, BLR DJ, ZPT for pentograph selection, forward pento or reverse pento, one or two. A loco normally have two pentos, one in diverse side and one in the reverse side, that you have to select. Then your first you have to run the baby compressor, because when the loco is not energized, you have no electricity, nothing. So battery, you have to depend on battery. Battery will prepare the compressor air, baby compressor it is called, and it is only supplying the Pento to rise. Once Pento is raised and loco driver will energize the loco, then we have three compressors, main compressors. So this will supply the air pressure for pneumatic purpose, and the role of baby compressor is only to raise the pantograph, and with this air pressure will close the DJ. Will close the DJ. After closing the DJ, we have no problem. And in the Mtdj is for safety relay, all are on its branch. All safety relays are on its branch. If any safety relay will energize, QLM is for overcurrent relay, silicon block overheating, that is QRSI1, QRSI2, traction motor overload, this is QP1, QP2, and QA is for auxiliary motors, 13 auxiliary motors it is for. These are called in loco, our traction locomotive TRS language, it is bonding relay. What is bonding? That is all electrical circuit we kept in such a way that any short circuit and anything, it will be arrested by all these relays. That is, we have interconnected with each other. But normally in open condition, this circuit is, but when there will be a fault, it will be closed and the relay will be energized. And just like our traction system, our transformer, secondary transformer, one end is given to the overhead and another is given to the railway track. But between this, there is no connection. It is in open condition. When train will come, it has load, so no problem. But when loco problem, loco overcurrent relay or over voltage relay, it will act, then our CB will trip in the, and if your OH is fallen on ground, then also it will not be open circuit. The circuit will be completed without any load, and short circuit will occur and CB will trip. So in our traction system, we are bonding all the traction, all the conducting material in the close vicinity of our overhead system. This is bonding. Bonding means you have to flow the dangerous voltage to the railway track in our traction system so that human will not get electric shock. Within 20 meter of our railway overhead system, any conductor more than 20 meter or more length, it can give hazardous shock. So we are keeping all this connected with the railway track with the neutral, and you will not get shock. In the railway traction loco also, all these things is in bonding condition. That means any short circuit or anything, a relay will be energized and it will trip the loco. It will trip the loco. For auxiliary, it is QA, auxiliary bonding relay, and for power circuit traction motor, it is QOP1 and QOP2. And for silicon block, QBS1, QBSI2. And overcurrent, that means your low traction transformer inside loco is short circuit. It will draw high current from the 25 kV side. So this QLM will energize. There is a CT, just like our TRD system. There is a CT. When current will be more, over current relay will energize and trip the energize the Mtdj, and the DJ will be open. DJ will be open. A beautiful thing is electric loco. It is somewhat separate from the daily life. In traction system, at least the transmission, distribution, substation, these are somewhat but local is a special subject. Local is a special subject and very nice. How nicely they have controlled this local. But nowadays, this three-phase technology has come. The system somewhat changes. Variable voltage, variable frequency system has come. IGBT and GTO included gate bipolar transistor and gate turn off. This system has come. Later I'll tell about it, which how far I know it, because I have worked in this type of loco when I was performing the assistant loco pilot for 2 years in Eastern Railway. But due to the training in the in Nasik, we have a good professor, Dr. Ravindra Bhargava. Oh, what a nice man! He taught us about the new generation locomotives, this three-phase induction motor, traction motor. Okay, friend, today up to this, later we'll talk. Let's see if you can understand it or not. Hello, friend. Now it is 11 p.m. 35 seconds. Till now, I am working because today morning I have shown you the DJ controlling circuit, and there you have seen first Mtdj is energized and then Efdj is energized. Efdj is called the closing relay of DJ. So what is happening? From the main reservoir, the compressed air enters into the RDJ. Air pressure reserved in the RDJ. Now, first we have seen that Mtdj is energizing. When Mtdj will energize, the Mtdj coil will pull the plunger towards up direction. And what will happen? The air pressure will be exhausted from the left hand side of the chamber of the DJ closing reservoir. You have seen that two space is there. One is right hand side. This is for EFDJ, air pressure receiving, and in the left side this is for Mtdj, air pressure to maintain the DJ in closed condition. It is maintaining Mtdj. But in the DJ closing circuit, we have seen first Mtdj will energize, then Efdj will energize. Mtdj will release the air in the left side of the chamber, and when Efdj will energize, it will send the air pressure to the right hand side chamber, and the DJ will close. The DJ will close. So this is the system. See how it is happening. But in the next slide, I'll show you the animation. In here, I am showing you the just the basic. Okay. Friends, this is PowerPoint animation, and it is better for teaching aid. But accurate animation, it is the it is expensive, and that budget is difficult to bear for without a very big institution. But in home I am doing this. I have tried to tell you the operation. The Mtdj first energized, and the air pressure in the left side of the chamber is released. Then Efdj energized. Then it will allow the air pressure to the right chamber and press the piston to close the TJ circuit breaker, and the 25 kV energize the main transformer. This is the basic idea. So what we have learned, we are closing this 25 kV switch with the help of this electromagnetic and electropneumatic operation. This EFDJ, Mtdj both have magnetic coil. It will pull the plunger to the upward and will allow the air pressure to its where it is required. But Mtdj is for maintaining the DJ closed position. DJ closed position. But when Mtdj, after charging the after closing the circuit breaker, when Mtdj will energize, it will trip the circuit breaker. The left chamber will press the piston to move towards the right side, and that circuit breaker will open. You have seen that so many safety relays like QLM, QOP, these are all safety relay. QLM is overcurrent relay. Energization of any of these relay will open its contact from the Mtdj branch, and the DJ will trip for the protection of the loco, because these safety relay all are for safety of the loco. That means these all relays are harmful for locomotive. If any fault is in the locomotive, this normally closed contact will open and trip the circuit breaker. Okay friends, today up to this. Later I'll tell it in details. Okay.